Simplify the radical expressions. Our first one is the square root of negative 45, which we know we have to rewrite it so it's a positive radical with our radical of negative 1. We know the radical of negative 1 is I, and then we're looking for perfect square factors of 45, which is 9, so we can rewrite it as square root of 9, square root of 5i. We know the value of the square root of 9 is 3, so we'll have 3i squared of 5. Here we have the radical 3 times the radical of 21. No perfect square factors here for 3 and none for 21, so we could multiply them together underneath one radical. We also know that 21 comes from 3 times 7. And so if we think about it, thinking for perfect squares, 3 times 3 is 9, that's a perfect square. And we know the value of the square root of 9 is 3. So when we're simplifying this, we'll have 3 square root of 7. Then we have the square root of 400. Well, that's a perfect square factor, and the value of the square root of 400 is 20. Now we've been simplifying radical expressions when we've been solving quadratic equations and also sometimes with our absolute value equations. We want to see an application of when we would be using our radicals, and that can also be with our figures. And so one of the figures we've been studying is a right triangle. And you may have seen this in the past, that the Pythagorean theorem says the sum of the two legs squared for a right triangle equals the square of the length of the hypotenuse. The two legs are the ones that form the right angle of the triangle. They may or may not be congruent depending on what the angles are for the triangle across from the legs. So again, remember the sum of the two legs squared is equal to the hypotenuse. Sometimes we use the variables a, b, and c to represent the sides of the triangle. A and b are typically used to represent the legs, and c is used to represent the hypotenuse. So again, for right triangles, this relationship exists. So for the following pictures, which do you think the Pythagorean theorem applies? The Pythagorean theorem applies to right triangles, and by looking at our figures, it appears that triangles 1, 3, and 5 have right angles. Therefore, we could use the Pythagorean theorem to solve for any missing side lengths of those right triangles. So let's put the Pythagorean theorem into practice. Here we have our right triangle, two legs of 8 and 6, and our hypotenuse is unknown. We want to find the length of the hypotenuse. Well, the Pythagorean theorem says take the sum of the two legs squared to equal the hypotenuse squared. Well, here's my two legs, 6 and 8, and if we square them, we'll have 36 and 64 to give us a total of 100. We want to find the length of the hypotenuse c, so in order to undo this, we'll square root each side of the equation. We know that the value of the square root of 100 is 10, and when we take the square root of c squared, that gives us the absolute value for c. We've talked before about how the absolute value measures the distance from 0, so we have to travel 10 units to the left and right of 0. When we go to the left 10 units, that means we'll end up at negative 10, and when we go to the right 10 units, we'll end up at 10. And again, we want to see if both of these will work for our triangle. So you want to ask yourself, can you have a side length of negative 10 units? That is not possible, so that would be an extraneous solution. Can you have a side length of 10 units? Yes, you can. So that would be a solution that we could use for our triangle. So the side length that we're missing is 10 units. Let's have you try another one. Can you find the length of the unknown side of the triangle? So here we're looking for y. Y represents one of the legs of the triangle. We have one leg of 5 and a hypotenuse of 8. So using our Pythagorean theorem, we can solve for our unknown. So we've got 5 squared, which would be 25, and 8 squared would be 64. We're trying to get y alone, so I would subtract 25 from each side of the equation. Now we've got y squared equals 39. To undo something that's squared, take the square root. We know the square root of y squared is the absolute value of y. And then we want to think about the square root of 39. Does that have any perfect square factors? It doesn't, so we're going to leave that as is. We do have to travel this distance left and right from 0, though, to see what we end up with. Well, if we go left, that distance of the square root of 39, we'll have a negative square root of 39. And if we go to the right, we'll have a positive square root of 39. Again, which of these fit for our triangle? We can't have a negative side length, so we're going to have to eliminate that for our solution. So here we have our missing side length be the square root of 39 units. Let's have you try another one. Find the unknown side for the triangle. Here one of the legs is missing, so again, the sum of the two legs squared equals the hypotenuse squared. Follow your order of operations to get the unknown squared by itself, and then square root each side. The square root of x squared is your absolute value of x, and the square root of 200 has a perfect square factor of 100, and then 2. So this would simplify to 10 square roots of 2. Again, go left and right your distance from 0, and see which of these will apply for your triangle. We can't have a negative distance, therefore our side length is going to be 10 square root of 2 units. Find the length of the unknown side for this triangle. On this triangle, the hypotenuse is missing, so the sum of the two legs squared is equal to the hypotenuse squared. We've got 49 and 81 to give us a total of 130. If we square root each side, we'll have the square root of 130, no perfect square factors there, and we'll have the absolute value of y. Again, go left and right your distance of 0 and see what applies to your triangle. We can't have a negative side length, so our side length here is going to be the square root of 130 units. Find the length of the unknown side for this triangle. We're missing the side length of a leg, so we'll substitute in our values to our Pythagorean theorem. The sum of the two legs squared equals the hypotenuse squared. And we'll follow through with our order of operations. So this will give us a 1. If we square the square root of 10, we'll get 10. And remember, if a quantity is squared, that means you have two of them that are being multiplied together. So if you distribute every term from the one binomial to the other, we'll have x squared plus 2x plus 2x plus 4. Combine your like terms on each side of the equation. So here we could have x squared plus 4x plus 5 equals 10. We now have a quadratic equation. So whenever you're solving quadratic equations, they must equal 0. I would subtract 10 from each side of the equation. Here with your quadratic equations, you could solve them either by factoring, quadratic formula, completing the square, or by graphing. Because the numbers are fairly small, I would ask yourself, what times what gives you negative 5? What plus what gives you a positive 4? Here we could use a positive 5 and a negative 1, so factoring would be a good option. Remember, when solving by factoring, you take each factor and set them equal to 0 and solve, because when you're multiplying two numbers together to get 0, one of them would have to be 0. So we set each factor equal to 0 and solve. That means that x could equal either negative 5 or x could equal 1. Well, again, you want to take a look at your triangle and say which fits the side lengths. Well, if I substitute negative 5 into our length of the leg here, we'll have negative 5 plus 2, which gives me negative 3. I can't have a negative side length, therefore I cannot use x equals negative 5. I'll try the 1. 1 plus 2 is 3. I can have a side length of 3. And if I want to double check, the sum of the two side lengths should equal the hypotenuse squared. So if I take 3 squared, that's 9. 1 squared is 1. That's my 10. Remember, it's going to equal the square of that. The square of 10 is 10. We're all checked. So the side length of the triangle is going to be 2 using the variable for x equals 1. Here we want to find the unknown length of our triangle. So I want to solve for x. In order to solve for x, I need to find a few other missing side lengths of triangles first to get there. So I assign some variable names, w, y, and z. I'm going to start by finding w, and once I have that, I can substitute it here, find y, and once I have y, I can substitute that here, work on finding z. Once I have z, that will help me find x. Well, by definition, the sum of the two legs squared equals the hypotenuse squared. Solving for w, got the absolute value of w equals 8. If I go left and right the distance, remember, I'm going to have a negative 8, and I can't have a negative for a length, so we're going to use 8 for a length for w. If I substitute that here, the length of the two sides squared is equal to the hypotenuse squared. So we're going to work on solving for y. Now remember, absolute value measures the distance from 0, so I would have to go negative 10 units and 10 units. I know I can't have a side length of negative 10, so my side length for y has to be 10 units. Well, now I know that this side length here is 10. I'm going to use it for my next triangle to solve for z. The sum of the two legs squared is equal to the hypotenuse squared. So the absolute value of z equals the square root of 576. Remember, we're going to go that distance left and right from 0. We can only use the positive length, and 576 is a perfect square. So I'm going to have my side length for z being 24. Well, now I know that this is 24. I have a hypotenuse of 25, and I'm missing that side length. So again, the sum of the two legs squared is equal to the hypotenuse squared. So I'm going to use that to solve for x. So here we'll get the absolute value of x equals the square root of 49 is the value of 7. Again, we would go left and right our distance from 0. Well, I can't have a negative length of a side length for a triangle, so negative 7 is eliminated. That means x has to have a length of 7 units. Now it's your turn to practice by doing the Unit 9, Day 2 homework worksheet.